Namaskaram. This is again a question from CSAT 2024. Now, if you look at the case, on January 1st, on January 1st, so this is question number 10 from set A. On January 1st, the person is saving rupees 1. On January 2nd, he is saving rupees 2. He's not saving rupees 2. He is saving 2 rupees more than the previous day. So, let me note that down. So, on January 1st, he is saving rupees 1. On January 2nd, he is saving 2 rupees more. That is 1 plus 2. So, 3 rupees. On January 3rd, he saves 2 more than the previous day. So, the previous day he has saved 3 rupees. So, here he will be saving 2 more extra. That is 5 rupees. And so on. And the process keeps on going on. And at the end of which date was his total saving a perfect square as well as a perfect cube? So, if you look at the case, let's write down the case. January 1st, we have 1 rupee. January 2nd, we have 2 rupees. January 2nd, we have 3 rupee. He's saving 3 rupee. January 3rd, he's saving 5 rupee. January 4th, he'll be saying 5 plus 2, 7 rupees. January 5th, he'll be saying 7 plus 2, 9 rupees. January 6th, he will be saying 9 plus 2, 11 rupees, and so on. It will keep going. Right? Yes. January 9th, he will be saying 2 more, 17 rupee, and so on. So, let me write it properly. 3 and 5, 3 rupees and 5 rupees. If you look at this is basically an AP. Okay? Because the first term is 1, second term is 1 plus 2, third term is 1 plus 2 into 2. This is 2 into 1. Third term is 1 plus 2 into 3. This is 1 plus 2 into 4, and so on. It is a AP with the first term as 1, common difference D as 2, and so on. Now, the next part of the question, okay? Next part of the question is saying at end of which date was his total saving a perfect square? See, right now we are having the number which is saving per day. His total saving means they are basically asking for sum of the terms. So if you look at the sum of the terms, his total savings will be, on the first day it will be just 1 rupee. On the second day, along with this 1 rupee, he is saving 3 more. So 1 plus 3, his total saving will grow to 4 rupees. On the next day, his amount, he have already a saving of 4. He's adding 5 more rupee to that. So his total saving will become 9. On the third day, his total saving will become rupees 9. On the fourth day, it is 9 plus 7. 9 plus 7, his savings will become 16. Next day, again adding 9 to 16 rupees, it will become 25. Third day, he's adding 11, so it will become 36. Next day, so he's adding 11, 36. Next day, he's having 13, it is going to become 49. Next day, he's adding 15, it is going to become 64. And again, next day, he's adding 17, the amount is going to become 81. Now, if you look at this thing, you can also notice one pattern. So, what we found is sum of the n terms. Sum of first term is this. Sum of first 2 terms, 1 plus 3 is this. Sum of first 3 terms, 1 plus 3 plus 5 is this. Sum of first 4 terms, that is this. Anyway, you can also see a pattern over here. The pattern which you can see over here is that this is the first position. January 1st, we have the first position. On the first term, it is 1 square. Here, the value which you are getting is 1 square. On the second day, you are getting 2 square. On the third day, you are getting 3 square. On the fourth day, you are getting 4 square. And it keeps on going like that. 5 square, 6 square, 7 square, 8 square, and 9 square. But the question is asking, at end of which date was the total saving a perfect square as well as a perfect cube? What is the meaning of a perfect square and a perfect cube? See, perfect square. Perfect square. If you take any natural number and if you square that number, you are going to get a perfect square. That means 1 square. 1 is a perfect square. 2 square. 4 is a perfect square. 3 square, 9 is a perfect square. 4 square, 16 is a perfect square. So if you take any natural number and if you square it, then you are getting a perfect square. You can say the other way also. If you take a number and if you take the square root, if you are getting a natural number, if you're taking a number, taking square root, if you're getting a natural number, if you're taking a number, you're taking square root of that number, you're getting a natural number. Then those original numbers of which if you're taking a square root and you're getting a natural number, those numbers are known as perfect square. So the perfect squares are 1, 4, 9, 16, 25, 36, so on. Okay. Now, this is a perfect square. Similarly, perfect cube. If you look at what is a perfect cube, take any natural number, you cube it. You are going to get 1, 2 cube, 8, 3 cube, 27, 4 cube, 64, 5 cube, 125. These numbers are known as perfect cubes, the cube of the natural numbers. Or inversely, I can also say that if you take the cube root of a perfect cube, you are going to get a natural number. Cube root of a perfect cube, you are going to get a natural number. Cube root of a perfect cube, you are going to get a natural number. So this is the basic definition of a perfect square and a perfect cube. The same perfect square and perfect cube can also be understood using prime factorization. If you take these numbers 1, 4, 9, 16, etc. 1 is simply 1. 1 is a God number. You cannot play with 1. So let's take from the next number. Next perfect square which we have is 4. That is 2 square. Next one is 9. 3 square. Next one is 16. Right? 16. That is 2 raised to 4. Next one is 25. That is 5 square. Next one is 36. 2 square into 3 square. Once you prime factorize these numbers, if the powers are multiples of 2, all the powers are multiples of 2, then such numbers are known as perfect squares. Okay. Similarly, if you take the numbers over here, we have, let's ignore 1 because 1 is a special number. 8, 27, 64, 125. This is 2 cube. This is 3 cube. 4, 2 raised to 6. Right? Yeah, 2 raised to 6. This number will be 5 cube. If a number has to be a perfect cube, what you have to look at is that after prime factorization, the powers should be multiples of 3. So if the powers are multiples of 3, then you will get a perfect cube. So if it is a perfect square, the powers should be multiples of 2. For a perfect cube, the power should be multiple of 3. Okay. Now the question is asking you to find such a number which is, we are looking at the total saving at here. The total saving should be a perfect square and a perfect cube. And of course, the first number which is a perfect square and a perfect cube is 1. But, so on the January 1st itself, you are supposed to get the savings which is a perfect square and a perfect cube. But that is not given in the option. It is given not possible, but of course, this is not the case because it is actually possible. So this is not the answer. And for some reason, the January 1st is not given in the option. At the end of which date total savings is perfect. So they are basically asking us for some other value just greater than 1, which is a perfect square and a perfect cube. If you look at these numbers, you can keep going forward. Okay, you have lots of perfect squares over here, and if you keep going forward, 5 square you will have 25, 6 square you have 36, 7 square 49, 8 square 64, 8 square that is 64. Similarly, 4 cube is also 64. There is no other number before. See, 1, 8, 27. You cannot find 1, 8, 1 is there. That's why I said that can be a possibility, but that's not given in the option. 8, 27 is not given over here. So the first number, which is both a perfect square and a perfect cube, is 64. Okay. So we are looking for a number where the savings is going to be 64. See, savings is 64 on the 8th day. So therefore, I can simply say that on January 8th, Mother saving is going to be 64, which is a perfect square as well as a perfect cube. Now, instead of writing all the numbers like this and then finding the number which is both perfect square and perfect cube, we can directly make a method to do the same process. Because I just told you that if a number after prime factorization, if the power is a multiple of 2, then it is a perfect square. If the power is a multiple of 3, then it is a perfect cube. If a number has to be both perfect square and perfect cube, then the power of, so after prime factorization, the power of such number should be both multiple of 2 and multiple of 3. So, the power should be a multiple of 2 and 3. A number which is a multiple of 2 and 3 will basically means that this number is a multiple of LCM of 2 and 3, least common multiple. We are looking for a common multiple. The common multiple of 2 and 3, since they are both are prime numbers, LCM of 2 and 3 is 2 into 3 is 6. So we are looking for those such numbers whose powers are divisible by 6. That basically means that 1 raised to 6, of course, that is 1. Let's ignore that guy. 2 raised to 6, that is 64. That's the first number which we found. The next number will be 3 raised to 6. That is not an easy number to find, but for the time's sake, I'm writing it 729. The next number will be 4 raised to 6. 4 raised to 6, that is 4096. And it keeps on going. All these numbers are perfect cubes, at the same time perfect squares, because it is the powers are divisible by 6. So the smallest number other than 1 is 64. Now in this way also you can come to the same conclusion. The savings becoming 64 on the 8th day. Okay, again the answer is going to be B. Now one more method is there to find, instead of just adding all the numbers, we can also use the properties or the formula for finding the sum of AP. If we have an AP, okay, in an AP, sum of first n terms, the equation is n by 2 into starting number, sorry, there's a multiple of 2. 2 into A1 plus n minus 1 into D, where D is the common difference. A1 is the starting term. In our equation, we know that the starting deposit which the person did, or the starting term is 1. See, the starting number is 1. And the common difference between all these numbers are 3 minus 1 is 2, 5 minus 3 is 2, and so on, 2, 2, 2, 2, 2, 2. So, the common difference D is 2. And we are looking for a place where the sum is going to be 64. Let's see, we don't know if it is going to become 64 or not. Let's substitute that value and see. Okay, of course, since we solve it, we know, but in this case, we are looking for a place where the sum is gonna be 64. We don't know which day or which term it is going to be like that. So first term is 1 plus n minus 1 into 2. So if I take these two common outside, because there is a sum between, if I take these two commons outside, I'm going to get this value as n by 2 into, and that 2 comes outside, into 1 plus n minus 1. This brackets also will go, and plus 1 and minus 1 will get cancelled, 2 and 2 will get cancelled. You will find 64. 64 is equal to n into n, or 64 is equal to n square. So that basically means that n will be square root of 64. Of course, plus and minus will be there, but here we are looking for the position. So it will be a positive number. So n is going to be 8. In this way also I can find the 8th position, the 8th day. We are going to get the savings, or the sum of the AP is going to be 64. Even then the answer is option 8. Now one more way is there. Of course, if you observe the pattern over here, the sum is going to be square of the first term. 1 square, 2 square, 3 square, 4 square, 5 square. Just like that, we can see when it is going to be 64. 64 will be happening on 8 square day. So again 8th day. So multiple ways are there to come to the same solution. Anyway, it's a combination of AP, perfect square, prime numbers. A lot of different topics are there, but it's a very beautiful problem. And that's it with this problem. Thank you.